Okay, what we're going to do today is we're going to finish looking at the implementation, the table lookup implementation of a finite state machine, and then we're going to do a direct code implementation of the finite state machine. So our topic in general is finite state machine implementation techniques. Now, just to review where we were at the end of class last time, what we are looking at is a table lookup implementation of a finite state machine. And here in figure 7.12 is the state transition table for the finite state machine that we're going to implement, that the program is going to actually produce. It's going to execute this finite state machine. So if you recall, this table recognizes identifiers. In other words, we assume that there are letters and digits, and then an identifier starts with a letter and it can have any number of letters and digits following it. And then at the end of class, or in class last time, we demoed. Here's figure 7.28 is what we demoed. Cab 3 is a valid identifier. And we looked at JavaDoc. And in class, we were starting to do a code walkthrough. And here in figure 7.28 are the states. So remember what the states are? The states are integers. Now so we have static final int s underscore a equals 0. Now what does static mean?
One per class.
One per class instead of one per object. Final means? Constant. Okay, so this is how you do const in Java. And int is type int. And SA means state A. That's the idea behind that. S underscore A, so that's state A, and that's just 0, and then state B is 1, state C is 2, and then T letter is 0, T digit is 1. And here what we were looking at at the end of the class last time is, you see this static final int FSM. So FSM, what is the type of FSM? It is a what? It is a two-dimensional array of what? Integers. Yeah, so it's static final int. Yeah, so it's fixed. The finite state machine will never change. It's a constant. Is everybody clear on this? And remember what we said? We have 3 rows and 2 columns. Right? And what's in the table is BC, BB, CC. And that corresponds directly to this state transition table in figure 7.12. BC, BB, CC, right? So everybody see how that corresponds directly? And now you guys, here is action performed. So this is what happens when we click the button and actually run the program. So now to illustrate this, we're going to do a trace. We're going to trace through it. Now, what variables do we have in here? We have line. Okay, so here's line. What other variables do we have? CH is a char. Is everybody good? And what else do we have? FSM char. And what else do we have? Now look at this. What else do we have? What's next? State. Now here, this is a key concept of all implementations of finite state machines. What we have is what's called the state variable. All right? And this state variable tells us in the computation what state we are in. Are you with me? So this is the state variable for this computation. So we have int state gets what? S underscore A. So so this is state, right? And furthermore, that state variable is initialized to what?
0.
S. Yeah, well, it is 0. You're right, it is 0, but we want to this is self-documenting code. We don't want to just have zeros and ones and twos all over the place.
Okay.
We want to remember what they stand for. Yeah, that is a good point, though. It is actually 0. Now, is everybody clear so far what these rules are? Okay, now, suppose then that when we did the demo, we had the dialog box and we put cab 3. Remember that? That was how we, cab 3. So in cab 3, when it says string line gets text field dot get text, what does that do? That puts cab 3 in here. Now is everybody good? Because action performed is what executes when you click the button. All right? And so when you click the button, action performed, and the very first thing we do in action performed is we do string line gets text field dot get text. So that text field is an element of, actually it's this. That text field is this in figure 7.28. It's that text input box. That's what that is. Are you with me? Okay. And you know those details about how all that dialog box gets set up. I have all the code for you. Have all the code in your online. You know when you download this, and on the slides you can look through that and you can kind of see how it works. But we don't have time to go over it, how all those details work. But anyway, you can work through that. So anyway, that's what text field dot get text does. It retrieves that text from that box and puts it in this string called line. All right, now let's take a look. For int I gets 0. Okay, so we have an I. That's another variable. And it's for int I gets 0, so I gets 0. And what is the test in the for loop? I is less than what? Line.length. Now what do you suppose the value of line.length is here? It's 4. That's the length. That's how many characters are in this line. Is everybody clear? Is everybody clear? So line.length is 4 because there's 4 characters in here, right? Okay. And now what's the next line? And is 0 less than 4? Yes. So we execute the loop. So what is ch gets line.char at 0. So what does ch get? That gets the letter C. Are we good? Are we good? Okay. And now what does it say? FSM char gets. So now this variable is going to get some value. Now what's it going to get? Is alpha ch question mark? So remember what our is alpha was here in the previous slide? We wrote a little Boolean is alpha. And what does it check? Whether it's a lowercase or an uppercase letter. And does everybody see how that worked? Okay, is alpha. So we're checking whether it's a, and so is alpha ch? So does that return true or false? If ch is C, that returns true. So what does FSM char get? T letter. Yeah. Okay. So T letter. Right? Is everybody clear? And now, you guys, what are we going to do in the next line? What is the next line? The next line is the what? What do we call it? What are we calling this technique? Which technique are we doing now? Are we doing direct code or are we doing table lookup? We're doing table lookup. So what is the next line? State gets what? FSM sub. Now what is FSM? A what? Well, no, but in Java, what is its type? Here in the previous slide, it's a two-dimensional array. Are you with me? So look, here it does State gets FSM sub what, sub what? FSM sub what? Sub-state. So what is that? SA, and what's the second dimension? T letter. So it's going to the array, to the table, and it's getting FSM sub A letter. So let's go up to back to our finite state machine. So what are the rows? The rows are what? A, B, and C, and the columns are what? Yeah, but not 0. Okay, the rows are 0, 1, and 2, and the columns are 0 and 1. But in our self-documenting, it's the rows are what? A, B, and C, and the columns are what? Letter and digit, yeah. Is everybody, are you with me on this? Letter and digit. So what is it here? So what's it looking up? FSM sub what? Sub what? A what? Letter. So let's go back to our table. So what is in row A, column letter? It's B. So what does state get? SB. Is everybody clear on that?
Can you go through that last part one more time?
Sure. So do you see that so far what we have currently is state is A, FSM char is letter.
Yes.
Are you with me? And here if we look at figure 7.8, what is in row A, column letter? You understand that the rows are 0, 1, and 2, and the columns are 0, 1. But we are naming them states A, B, and C, and columns letter and digit.
Okay.
So do you see that if we go to state sub A, comma, letter, what is the value of that table? SB. And so you see here the code says state gets FSM sub what? State FSM char. So it's looking up in the state transition table and it's making SB the next what? The next state. So we just made a transition in our finite state machine. Are you with me? Because we changed the state variable. It is slick. Yeah, good description. Slick. It's just table lookup. You just boom. Here's the code that does the finite state machine. We just changed the state. By changing the state variable, we changed the state. Now, does everybody see how that worked? And now we're at the end of the for loop. So now what happens? It's for I++. So what happens with I? It gets 1. And now it's for int I gets 0, I less than line. What is line dot length? 4. Is 1 less than 4? Yeah. So ch gets what? Line dot char at what? 1. So what is line dot char at 1? That's the A. So boom. Now this is A. Are we good? And now what happens? FSM char gets is alpha ch? Well, is alpha ch? Yes, so what happens to FSM char? It's no longer T letter, now it's T letter. Yuck, yuck. Right? And so now what happens? State gets what? State sub what now? sub what? B letter, right? So now what is B? So now this is row B, column letter, right? So that's what? Row B, column, so it stays what? SB. So now it's SB. We just made it, okay? Is everybody clear on that? So now do you see how, and we just go on till we get to the end? And so what's going to happen? What's going to happen? It'll be C, and then A, and then B, and then what will happen? I don't want to take the time to trace this every step, but do you see how to do it? So what's going to happen? The last time around, what's going to happen the last time around? The CA, I will be 4, right? Char at 4 will be a 3, so eventually this will be a quote 3, so dot dot dot, this will be a quote 3, and what will, and then FSM char will get what? We'll get digit, T dot digit. All right, T, and then we will look at what? And the state will still be, yeah, so it'll be in B and will be T digit, and so what will that give us? Row B's digit. It's still a what? SB. Right? And then in the end, now how do we determine if it's valid? We check to see if we are in a what? In a final state. And so what after the loop, what do we say? If what? State equals B. What? It's a valid identity. Else what? It's not. And you see, so look, if you go back here, that's how, you know, here in figure 7.28, that's how you put 3 cab. 3 cab is not a valid identifier. Now, is that slick? Yeah.
So in like this 2 slides before, where we're declaring what are the final states, aren't they all final states because they're all?
No. Look. Here in figure 7.12, B is the final state. And remember, actually, let's go back and look at the state transition diagram, just to refresh our memory. Okay, so remember that state transition table is the state transition table for this finite state machine in figure 7.11. And notice that B is the final state. So in the end, and remember, you remember how the parsing rules worked? Okay, so here's the parsing rules. You start at the start state, scan the string from left to right. For each terminal scan, make a transition to the next state on the finite state machine. After the last terminal, if you are in a final state, so notice after the last terminal, so there's the if statement after the loop. Yeah. Yeah. So are we good? Does everybody see how that works? Now, can you see, I don't think I want to demo this, but can you see this machine has a deficiency that you are supposed to fix in the homework exercise. Can you see what would, I don't want to take the time to demo it, but this machine has a deficiency. What would happen if you said cab parentheses, or sorry, not parentheses, you said cab %3.
It'll interpret the percent as a digit.
It will interpret the percent as a digit, and it will say that this is valid, but it shouldn't be. Do you see how this code here? Do you see how that code will do that? Because it says, what it does when it says if, it says FSM gets if is alpha a letter, and if it's not a letter, we are assuming it's what does the program assume? That it's a digit. So here it will just assume that it will assign this to be a digit even though it's not. So there's a deficiency here. So your homework exercise is to improve this, and you're going to need another. You're going to have to change the table, because what you're going to need is because now what are the possibilities? Not just letter or digit. It's going to have to be, what are you going to have to do here? Instead of just alphabet being T letter 0, T digit 1, what else are you going to need?
T others.
T other and make that what? 2, and then modify your machine accordingly so that it works correctly. Now, is everybody clear on how to do it? And you can turn that in tomorrow if you want. Yeah.
On these, how would you write up like an empty transition?
We're not doing, this is a full finite state machine, deterministic without empty transitions, and that's a separate, yeah. You understand you don't need that for this assignment either, yeah. And in practice what happens is you go through that process of eliminating the empty transitions anyway, so it's rare that you want to actually implement a non-deterministic finite state machine in practice, because we can prove, it's been proved in automata theory, you'll learn this, that all non-deterministic finite state machines have equivalent deterministic finite state machines, and there are algorithms to convert from any non-deterministic to an equivalent deterministic. Okay, good question. Now are we good? Does everybody see how to do the homework? Okay, now, I have some bad news. Next week is spring break. But guess what? When you come back on Monday, there is going to be a what? A homework assignment. So I'm sorry to lay that on you, but facts of life. Okay? And guess what that homework assignment from Monday is going to be? It's not going to be a table lookup implementation of a finite state machine. It's going to be a what? A direct code implementation of a finite state machine. I don't know why they call spring break around here is so early in the year. I don't know. They should call it winter break. Yeah. I mean, here we are in February. Anyway, I think I'm going to keep that in the video too. Okay, so now you guys, what we're going to do is, for the direct code implementation, is we're going to implement this finite state machine in figure 7.20b. Now actually, and the reason this one is important is because we're going to use a technique in here that you're going to use in your project. Now, do you remember, or can you tell by looking at figure 7.20b what this finite state machine recognizes?
Signed and unsigned.
Signed and possibly unsigned integers. Yeah. So this machine should recognize, so is everybody clear? All right. So now, I think before we actually take a look at the code, I think what I'm going to do is I'm going to demo this. Because what we're going to see in the demo is that it not only recognizes the integer, it also converts it from a string to an integer to an int value. You see what I'm saying? It converts it from a string to an int value. So let's take a look at the demo. Okay, so here's our demo, and I think what we'll do is we're going to look at the code. I mean, we could look at the code here in NetBeans, but you know, it's here. But I think we'll do the code walkthrough. Oh, by the way, notice that we're going to have 3 different classes here. We have a main and a parser and a state. So the code's going to be spread out with 3 different files. We'll take a look at the code when we get back to the slides. But for now, let's just run this and take a look. Okay, so now here in figure 7.29, what does it say? Enter a number. So if suppose we are rebellious, and instead of entering a number, we enter some letters. What do you suppose, and then we click parse, what do you suppose is going to happen? Will it crash? No, it'll just say what? Invalid entry, okay? So now, watch this. Let's put in like 583. Now if we parse this, what does it say? Number equals what? 583. Now, what it did is it did more than just recognize it. It actually converted that, because this text field, it gives us a string. So it actually converted the string, this character string 583 to its value 583. And here we can see if you put, look, if you put a plus sign in front of it, like this, and we parse, guess what happens? 583. See, so it knew that that was, but look, if you put a negative here and you parse, it converts it to negative 583. Does everybody see how that works? And you know, if you mess up and do minus plus 583, what's going to happen? Yeah, invalid entry is right. So does everybody see how, does everybody understand the demo? So what it does is it's going to convert that string to the actual int value, in addition to determining whether it is valid or not. All right, so that's our demo. Okay, so now let's see how our program does, how our direct code technique implements this finite state machine. So here in figure 7.29 we have example of what we just did. And here, now, in this part of, this next slide, let's take a look, before we actually take a look at the code, let's see how this works when we do action perform, because there's, so let's do a code walkthrough and see how we can figure out how this code works. Now, so what's the very first thing? String, actually, okay, so let's take a look at what this code does with action perform. So first thing that happens is we have type string, line gets text field dot get text. Does everybody understand that? Line then gets that string of characters like hyphen 583. Is everybody clear on that? And now what gets called? Or sorry, now what happens on the next line? Capital P parser. So because it's capital, that means it is a what? A type or a class. Is everybody clear? And then underscore P, that's our object. Right? That's like an object is like a variable with a class. And so underscore P is the object, and it gets what? New capital P parser. So now underscore P parser has been allocated, and it is a parser. Are you with me? And now, what can you tell on the next line? What does a class have? What are the two things, you know, in a UML diagram? Yeah, so what always goes here in the UML diagram? No, what goes here in the UML diagram? The what of the class?
Oh, the name.
The name of the class. So here's our class, parser. And what always goes here? The attributes, not public or private, and or private. And what goes here? The what?
Methods.
The methods. Is everybody remember? Okay, the class has attributes and methods. Okay, so now what can you tell on this next line? What is one of the methods? Parse num. Now, is everybody clear? So that means, okay, so and what is its type? What does it return? Is it void or non-void? It's void. So here we know we have a void parse num. You know, etc. You know, the parameters. Okay, okay, this is all review, right? Object-oriented programming. Okay. Okay. And so, now, so we know it has. Now, what about the next line? If parser dot get valid. So now, what does that tell us? The parser class must also have a what? Must have a get valid. And is it void? Yes or no?
No.
No. What does it return? Type Boolean. Now, is everybody clear on that? So we're going to expect, when we take a look at the code, we're going to expect to see a method called getValid, and it's going to return type Boolean because we're using it in an if statement. Is everybody good? And now what happens on the next line? So if parser.getValid, what happens? System.out.printf what? Number equals, and then the placeholder for the number, and bash n, and what? Parser.getNumber. So now what does that tell us? There's going to be a method called getNumber. So how many methods do we have so far by looking at this? We've got parse num, we've got getValid, which returns a Boolean, and getNumber, which returns a what? Well, what do you suppose the type is going to be? It's int. Now, is everybody clear on this, on how this gets used? Are we good? Sum gets int. Okay? And then else system.printf invalid entry. Now, does everybody see how, does everybody understand what's coming up now and how we can deduce that from how these methods are used? Are we good? Okay. All right, so now let's take a look at the methods. Now remember we saw when we were in the NetBeans, we saw that there were 3 separate files. So, and this is going to be typical in the convention in Java is to have every class have its own file. So now we're going to start doing that now. So we're going to have one whole separate file that contains the state. Now, you remember that here in figure 7.29, we have public enum state, and what are the states? SI, SF, SM, but now we have another one called what? Stop. So now if we go back here and look at our finite state machine in figure 7.20, we have an I and an F and an M, but now when you do the direct code implementation, you have to add an extra one called the stop. You know, it's going to be stop. Are you with me? So that's just something in the direct code technique, you've got to have an extra one called stop. To control when you stop the loop. Okay, is everybody clear? Okay, so that's an enum. Now actually so that's an enumerated. So you can think, it's useful to think of it as S sub I being 0, SF being 1, SM being 2, and S stop being 3. I mean, you can think of it that way if you want. But we'll use the names here. Are we good? So everybody, just like we did before with those ints. All right? And now here is class parser. Now check it out. Now what in this UML diagram, the first one has the name of the class. What goes here? And the second one always? Attributes. Now what attributes do we see, do we have here in figure 7.29? What attributes? We have valid and what? Valid and number. Is everybody clear? So valid is type what? Yeah, so valid is type Boolean. And number is type what? It's type int. Is everybody clear? So those are attributes. And look, what does getValid do? Now here's the implementation of getValid. Remember how we saw getValid in the previous, how it was used? Remember here in the previous, here it says, we said if parser.getValid. So what does getValid do? It just does what? It just returns this. It just returns whether or not it's valid. It just returns this. Now is everybody clear on that? Is everybody? And what does getNumber do? It just does what? Returns its number. You know, there's a software engineering terminology for this. These are called getters, for obvious reasons. Right? I mean, getters, it returns the values of the attributes of the class. All right, is everybody clear? So this is kind of like standard practice. All right? And now we have another one, private Boolean digit. And this one wasn't shown in the main program, but the class is going to use it. And it's private, so that indicates that the class is going to use it and no one else is. And what is it? Is digit, and it returns type what? And you see from the code there that it returns true if it's the digits 0 through 9. The character digits 0 through 9. Is everybody clear? Are we good? Now, I think you're going to like this. This is super. This is, you think the previous one was slick. Watch this. Here what let's do is this. Let's do a trace of this. Now what variables do we have here? What variables do we have? Line. Now is that a local, where did line come from? It's the parameter. It's the formal parameter. Are you with me? So because we passed that in. So here we have line. Now what else do we have? What local variable here? What other local variable do we have? Next local. Line index. What other variable do we have? Next char. What other variable do we have? What other variable do we have? Sign, and that's an int. And what other variable do we have? What's the next variable? Valid. Oh, actually, that valid is actually, notice it doesn't say Boolean valid. Why not? Because valid that's the attribute, right? It's already declared as an attribute of the class. Is everybody clear on that? So, are you with me? And now the next key one is what? State. And so what do we call that? That's the what variable? That's the, what do we call that in the previous implementation? That's the state variable. Okay, that's our, so in this implementation we still have to have a state variable, and its value is going to change, but it's not going to change by looking up in a table. It's going to change by the code's going to change it. So we have state. All right, now watch this. Let's trace this, and let's say that we entered a negative 583. So let's say that when Parsing Rules got passed, the line was quote hyphen 583 quote. Now, is everybody clear on that? So let's say that that's what happens. All right. Now let's take it one line at a time. Now what happens? So we call it with line being minus 580 hyphen 583. Now what does the first statement do? Line gets what?
That's a tab.
Oh, yeah. So what is that plus? That's string concatenation. So does everybody see that that first statement changes this minus 583 to this? Quote, minus 583 dash n. That concatenates the new line character at the end. And the reason we want to do that is because we want to guarantee that there is a new line character at the end of our string. Because the user, we don't want to require the user to put a new line in the, you see, but we want to guarantee. So that, and furthermore, this guarantees that there is at least one character in our string. So in our loop, we are guaranteed that we can go through the loop at least one time. Now, does everybody see that reasoning, that logic? Then what does it do? Int what? Line x gets what? 0. So there you see that everybody see that does that? Then what does it do? Char next. That just declares it, doesn't change the value. Then what does it do? Declares what? Int sign gets what? Plus 1. Now, this might seem a little redundant, but this is for self-documentation. Plus 1. Then what does it do? Valid gets what? True. So valid gets true. Then what does it do before it enters the loop, the do loop? Sets the state variable to the what? Yeah, the start state of the finite state machine. Are you with me? You remember these finite state machines? They always have start states, right? So we initialize the state variable to the start state. And so start state gets what? So this is s underscore I. So that's I. Now so now what's the next thing? Do, and where is the test for a do loop? At the top or the bottom? So let's go to the bottom. Boom. Do you see what is it? While state is not equal to state.s underscore stop and valid. But we'll get there. Okay. So now let's take it from the top. So do, so we don't, the test is at the bottom, so we don't do the test. Now what does it do here? Next char gets what? Line.char at what? Line index plus plus. That's not plus plus line index, that's line index plus plus. So what does that do? That takes, yeah, first of all, next char gets what? First of all, next char gets what? The hyphen. So first of all, next char gets the hyphen, and then what happens? Index plus plus. So, oh, here. And then this goes to 1. Now, does everybody see that that's what happens there? Okay. And now check this out. Switch state. Now, do you remember how the switch statement works? Switch. So what do? We evaluate we evaluate state, and we have case. Look what we have. We have case S underscore I, case S underscore F, case S underscore M. Right. So but what is our state? S underscore I. So we go to this first case, and then the break at the bottom will take us out of the switch. So watch what happens with this code. If next char equals plus. Well, does next char equal plus? Yes or no? But no. Nope. Else if next char equals what? Hyphen. That's the hyphen character. Does next char equal hyphen? So what happens? Sign gets what? Gets -1. Oh, this is such slick code. And then what happens? State gets what? SF. So this state gets SF. Are you with me, sports fans? And how did it change? What changed the state? In the code. This is direct code. That code changed it. You see, we're not looking up in a table. You understand what we're doing? We're not looking at the code changed it. And look, what does that correspond to in our finite state machine? What did we just do in figure 7.20b? We just went from where? I to F on a what? On a hyphen. Yeah, you see how we did it? You just look at the finite state machine, you see where you need to go, you just code it, you code it. Is everybody clear? This is how you're going to do it in your project. Okay? So, state, sign gets -1, state gets S dot, and so now else if, so we skip that, else we skip that, break, we skip the, are you with me? And we go all the way down to what? The while. Now the test is at the bottom loop. Okay, so now state is not equal to state is not equal to stop. True or false? True. Valid. True or false? True. So while that's, we go back and do it again. Now, did everybody see that? Yeah. Question?
Suppose you put in like.
Okay, I'll tell you what. Let's do. Let's postpone questions about what if questions. We need to get through this. Sorry to not answer your question, but let's hold off on the what if questions because we need to get through this. Sorry. But anyway. Okay, so now we do next char gets what? Line.char@. So now what? So now this gets, quote, 5. Right? Is everybody good? And then it's switch state. What's our state now? SF. So do we do SI? No, we go to SF. Are you with me? Now watch this. If is digit next char. Well, is digit. Are we good? It is. It's a digit. It is. So now watch what happens. Number gets what? Next char minus quote 0. Now what in the heck does that do? That changes this what?
Oh, changes it to like
This changes this character 5 to a what? To an integer 5, and what gets that? Number. Well, now we didn't put number up here yet, so we're going to have to put it up now. But you remember, number was that attribute. Remember? That was the attribute. So here, number. So this number gets 5. So that's how you convert from a character to an int. All right, little C-style stuff, right? Then what happens? State gets what? State gets what? M. Yeah, so you know we went now we're going, I remember the figure in M, okay? And we skip the else, we break. Now we're at the while. State is not equal to stop. Yeah, true or false? Valid, true or false? True. So what happens? Go back. Next char gets line dot char at what? Line index plus plus. So now what happens? This gets what? 8. And this gets 2. Are we good? It is 2. Switch state. What state are we in? SM. Now look at the code for SM. Watch this. Case SM. If is digit next char?
Yes.
Yes, because it is the character. It is the 8. So that's true. Now look what number gets. What does number get? This is the slick part. 10 times number. Now what's the current value of number? No, what's the current value of number? What's 10 times 5? 50. Oh, and then what do we add to the 50? Next char minus 0, which is the number 8. And so now what happens to that 5? Int 5, it changes to what? It changes to 58. I told you you'd like this. Is that slick? And then what happens? And else if, we don't do the else, we don't do that, we break, and what is the state stop? No. Valid?
Yeah.
So we go back, and what happens? Next char gets what? Line dot char at what? 2. So what happens here? This gets, quote, 3. This gets what? Integer 3, that's our index. And then what happens? Case what? SI. We stayed in SM, right?
Yes.
So we go to SM. And now what happens with SM? Is digit this? Yes. So what happens? 10 times what? 58 is what? 583. And then what does it do? 583 plus what? The digit value 3, 580 plus the digit plus the numeric 3, so this becomes what? 583. Are you with me? Okay? And then we skip the else, break, while, state, stop, valid, right? We go back up. And now what happens? Next char gets what? The new line, dash n. Right? And now what happens? Are we still in state what? M. If is digit? No, it's the new line that we installed there, that we're using now. Else if next char equals what? The new line. So what does number get? But what? Sign times number. But what is sign? -1. What's -1 times 583? -583. Is this cool? -583. Are you with me? And then what happens to state? Stop. So now you see why we have this S. Stop. We don't have a case on it because now when we get to the while, what happens? Yeah, it stops. And then later on in the program, when we ask if it's valid, valid will be true. And when we do get num, when we do get valid, it'll be true. And when we do get num, it'll have the value -583. That's how it got converted. And you can work through the code and see what happens if it's invalid, but that's the main idea. And so your problem for Monday is to do this with a hexadecimal value. So you should model your code just like this, but only each time you go through, instead of multiplying it in here, when we said number gets 10 times number, what should it be? Not number gets 10 times number plus something, it should be what? If it's hexadecimal, 16. So what you do is you replace that 10 with the 16. Are you with me? But then you also have to, you got to worry about hex digits, you know, you see what I mean? You got to worry about, now you got digits, and then you have A, B, C, D, E, F, and capital A, B, C, D, you see what I mean? So you're going to have to, you should write up a little utility to check if it's a hexadecimal character, and you got to do that. It's a little more complicated to do that, but it's the same idea. But look, I insist that you model it with just one do loop, one switch, and that's it. No more, no other loops, right? It has to have this structure in Parsing. It must have. You must follow this structure. Okay, that's for Monday. Are we good? So now you have something to do for when you get back, and we'll talk about it, I'm sure, some more on Monday, a week from Monday. All right, you guys have a good spring break.